Hello, everyone. It's nice to see lots of people here, especially at lunchtime. The talk is attacking the developer environment through local host attacks. So, let's get started. About me, I'm a security researcher at Contrast Security. Hopefully you've heard of them, but probably haven't. We make IASP and RASP and other security tools. We've got static analysis, source code analysis, other stuff, but the IASP and RASP are the interesting ones. I was a Java developer for about 10 years. After a while, Java development gets a bit boring when you're writing microservices week after week. They kind of get a bit samey. And so about 5 years ago, I moved into application security. This started a while back. I found a couple of, in and of themselves, not very interesting vulnerabilities in a framework called Toggles, an XSS and CSRF vulnerability. They were the first CVEs I found, but in and of themselves, not really all that interesting. However, the library that those vulnerabilities were found in is called Toggles, and a lot of you probably aren't developers, but there's a design pattern called feature toggles in software development, where if you have a feature you want to deploy to production, but you don't necessarily know if it's going to go very well, you can use a feature toggle to enable or disable it in production, and you can enable it for a set range of people. You can enable that feature for every X amount of requests by IP range, lots of different things. And this library was used to implement that feature, and it had a web console, which is where the XSS and CSRF vulnerabilities came in. But it also had a very interesting feature, which is you could enable or disable those feature toggles by implementing JavaScript on the JVM using the Nashorn feature within Java. So you write the JavaScript, and then that is then evaluated on each request and run on the JVM, and then based on the outcome of that evaluation, you get the feature toggle or not. But that means you can run arbitrary code on the JVM, and that's then run over a request. So that seemed like a much bigger potential issue than just an XSS or CSRF. So there was a CSRF, and that could be used to modify that or add a JavaScript to be run on the JVM in the server. But how to get that to happen? A CSRF you could use, but it's difficult. You need to know the path of the server. You would need to know the name of the feature toggle. So you need lots of kind of background and inside information to get that to work and then get right code execution. It's difficult. So anyway, I worked with the Toggles team, implemented the CSRF protection, but for a while it was bugging me. It seemed like there should be a better way of accessing this and then getting a much more serious vulnerability out of it than just simple XSS. But yeah. And at about the same time, there was a paper that came out on scanning your local host for doing essentially a port map from the browser of your local host or your local network, so any machines your browser can access. And that was being done by people like eBay to do fingerprinting of users. So I guess based on the port ranges that were available, they would be able to work out who you were, or probably as part of one of the many kind of things they use to work out who you are. But how does that work? Because normally a JavaScript loaded on eBay.com or whatever site shouldn't be able to access, or most people assume it can't access localhost or your internal network. So turns out you can, but it's very limited. You can make what's called a simple request, which is a request that isn't pre-flighted. So you don't have, before the actual request, you don't have a HTTP options method request sent ahead of it to check that you're meant to be able to make a request. Very limited, but that's what they use. And so the main limitation is you can't see the response. The request gets to the server, you don't see the response, but things like port scanning, what they were doing was inferring that there was a port open by doing a timing attack. So you check one port that's closed, should return relatively quickly. If you hit a port that's open, it will take slightly longer because that server has to process that request and respond, or whatever's behind that port. And so that's essentially how it worked. So limitations of simple requests. This is quite important for the rest of it. So you only have 3 types: head, post, and get. Head doesn't really matter, but post and get we'll be using later on. Content type is very limited. Form URL encoded, form data, text plain, or nothing. And that is also another interesting one of, if you don't send the content type, or you send a content type of null, you can sometimes access systems that you're not meant to be able to access, because if that server isn't checking the content type, you'll still be able to access it and then do stuff to the underlying system. And then there's a few other headers that don't really make a difference, like language and content language. You can set those as well, but it doesn't really matter. But again, you don't get a response back. Well, the browser gets response back. The JavaScript isn't showing that response. Slight difference there, I guess. So you can infer that you've made a impact to that server by maybe doing a timing attack, or if you eventually get remote code execution, you can potentially see it by maybe they're calling back to you, but again, it's limited. So that's what it looks like from the browser and what the JavaScript sees. That post request is a simple request to localhost from JavaScript loaded on a website. Well, there was a response. You don't see it. The JavaScript doesn't see it. Size 0, transferred 0, no response. Code. So to take a look at how it, give you a better idea of how it works. You have from a JavaScript loaded on some example.com site from the browser. Normally what happens if that JavaScript wants to make a request, before that the browser will make a options request to the server to check the access control. This time it's access control of wildcard, so it'll allow everything, and then you'd be able to then send the post request. But with simple requests, there is no options, so things like calls headers don't matter. You send a post request, and you get a response, but the JavaScript doesn't get to see it. So using that and seeing that toggles can be modified using a post request that matches the limited set of options we have, I was able to generate a payload. This is what it looks like. So this payload can be run on page load. So the attacker just has to get the developer or whoever else is using it to access that web page. They don't need to do anything else. There's no other interaction apart from loading the web page in a browser, or a browser that supports simple requests. I'll get to that later on. And what this will do is hopefully edit the feature toggle, set it to use the JavaScript feature type, and use runtime.exec to open up a calculator. And I like to live dangerously. I'll do a demo. So good, I can see it now. So start up the Spring application with Toggles library. This is what the Toggles web console looks like. So we can take a look, just to give you an idea. So based on that, whatever the activation strategy is, you can specify different things, username, IP address, and then it would change the underlying logic of the application based on that. But what we care about is this one, and then you can change this, set this, and then that will then be run on each request to the application. And so hopefully what we can then do is come out of here, go to here. This is available. There'll be links at the end, so you can go through this yourself if you like. And scroll down. Then go to here. This should run. Oh God, what did I just do? Click the wrong link. Payload link, and as you can see, we now have the calculator app popping up because I should. We've now modified it using a simple request. Open up a runtime exec, open up a calculator, and there we go. So that's great. Toggles isn't the most widely used application, but it's used by some developers in some companies, which is how I found it in the first place. So let's kill this. So we've been able to use the Toggles functionality to create a remote code execution on that machine. This is quite limited. You would need to be able to pull this off in real life. You would need to be able to get a developer to access a website you control. You would need underlying knowledge that they use Toggles, or just guess. And for Toggles specifically, there is a feature enum name that you have to know. This can be overcome. The main way I thought about this is creating just a tutorial website for Toggles. That way, the people using that website are highly likely to be running Toggles because they're running through the tutorials themselves. You'll know what the feature enum is because they'll be doing what you specified in your tutorial. And from there, you can get remote code execution, take control of the developer's machine. You might be able to do a similar thing using a malicious advert that has, say, Toggles as a keyword, depending on how loose the advertising rules are there on embedding JavaScript. But the main way would be through some sort of tutorial website. Something like this. Didn't actually create this, but either by getting control of this website like this or making your own, you'd be able to then get remote code execution on developers' machines, which is fine. But Toggles isn't that well known. Has thousands of installs, but it's not that common. So let's go to something a bit more common. Spring, which I'm sure more people have heard of than Toggles. So Spring has an interesting functionality called actuators. These are API endpoints that you can enable, or sometimes are just enabled by default, which some of them are simple. They have things like health indicators to see what the status of the underlying application. You get things like env, which is environment variables. These are normally read-only. Trace, which is very iffy. It gives you the entire HTTP request response of the server for the last like 10, 20 requests. Not your ones from you, but all of them. So if you see that on a production server, you can imagine what kind of fun you can get with that. And heap dump. There's another interesting one. If you get access to that on a production server, you'll have a fun time. It is literally a heap dump of the underlying memory of the application. So those are read-only. Some aren't read-only, and those ones we'll focus on. Env, which is sometimes read-only and sometimes not, which is a list of the environment variables and properties of the application. Again, even in read-only mode, if you can access it directly, then there's usually passwords and other things like that. Spring actuators should have a talk of their own. They are really fun. But also things like shutdown, reload, restart. So you can restart your application. Normally, these aren't meant to be run in production in a way that's accessible. But when you're running things on a developer machine, people tend not to put any protections in place because it's bound to localhost, and only I can access localhost. So if I want the shutdown actuator enabled, why not? I'm the only one who can access it. Or so people think. Yeah, this is a running theme throughout all of these libraries is people assume when it's bound to localhost, you don't need any other protections because only you can access them. So, the first one. So this is possible in Spring 1, Spring 2, and I believe Spring 3. So ones that are deprecated in even current versions. If they have the shutdown actuator enabled on localhost, you can, it's denial of service on a developer's machine. It's interesting and funny, but not that really useful as an attacker. So you can shut down their underlying application if they visit a website with essentially this payload that you can see. And again, the shutdown actuator is meant to have a content type of application JSON, which shouldn't be accessible from a simple request. However, it doesn't care that there is no content type because there is no, because you're not sending any value in the post request. There's no request body, so it doesn't check the content type is what is expected, and so you can shut down the underlying application. And this is a problem I did tell Pivotal, who own Spring. They weren't that concerned about it. It's only really useful for annoying developers. But that's interesting, and it's available in the latest version of Spring. But then there's remote code execution. This is again limited to Spring 1 and requires Spring Cloud dependencies, which is essentially something that lets you modify the environment variables from the /env actuator. My attack uses the H2 database, but as long as you're able to modify the properties of the application, you should be able to get remote code execution anyway, whichever way you look at it. It just takes a bit more time. And it requires the env and restart actuators to be enabled. And again, because the Spring actuators are almost always under a default path, you don't need to do any, as an attacker, you don't need to do any guessing. It's going to be on localhost, almost certainly on port 8080, then /env. So it's simple to generate this kind of attack. So this is limited to Spring 1. So quite an old version of Spring now. It was end of life in 2019. So quite a limited scope of people you can use to attack this. This is what it looks like, the attack. What we're doing is, hopefully some people at least at the front can see it, but I imagine the people at the back can't. There'll be links to all of this at the end, so don't worry about squinting too much. What we're doing is we're sending a post request to the /env actuator and modifying the Spring data source, which is the database URL. And we're changing it to be an in-memory H2 database. And then at the end, on startup, init equals run script from HTTP some evil site.com and then the exec.sql. So on startup, what will happen is the application should download that SQL file, and then from there we can do something else to it. One thing to remember, the only reason this works in Spring 1 is in Spring 1, actuators also allowed form URL encoded content type, which is available for simple requests. In Spring 2 and above, it's application JSON, and therefore we can't perform this attack, unfortunately. So take a look. So this is the SQL that gets downloaded from the website. This doesn't look like SQL because most of it isn't, it's Java. So H2 database is an in-memory Java database mostly used for developers. So they don't have to run like an Oracle or heavyweight database in their local development environment. They can have an in-memory database which is started up when the application starts up. And it's used for like general development and testing. But it has a feature which most databases don't, the alias feature, which allows you to create Java code on the fly. Create alias shell exec has blah, 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 string, shell exec, and after that, it's Java code. So we're generating a method called shell exec, and what that will do is call runtime exec, and then open up whatever process we pass in as an argument to this method. And then at the end, we've generated that alias function, and then we call it and open up a calculator. This is a slightly roundabout way of getting remote code execution, but it works. Again, as long as you can modify the application properties of the Spring application, there'll be other ways. This way I copied off someone. I forgot his name now, but his Twitter handle is Space Raccoon. So if you Google that, and I've got a link at the end to it, he used a similar thing to attack an application that had the env, that had similar things like this, but on a production system that he could directly access over the internet. So he didn't have to do any weird simple request stuff. So that's how you then get remote code execution on the machine. And again, let's do another demo. Take a while to start up. Okay. So this is a Spring 1 application. This is the env actuator. You probably can't see it very well, but this is all of the environment variables of the underlying OS and of the properties of the application. So there's lots of different actuators: info, health, giving you basic information about the health status of the application. So again, we can now go back. Click the payload link, and hopefully, again, as you can see, what's happening is we're making a post request to env at this point. As you can see, the calculator's popped up on the left-hand side. You then, which I forgot to mention, the next part is you then have to hit the restart actuator. So you modify the properties, hit restart, and then it restarts the application. And on application load, the database is started up, and that code is run, and you get the calculator popping up. So there we go. Remote code execution on Spring. Again, all you requires is to get a developer to access the website. And then we can shut down the application. Application's gone. So there's that. I'll talk about the last one in a minute. There is another one, Micronaut. Again, I've not shown that, but it also has a shutdown, restart, and a few other actuators where you can modify the application state. You don't get remote execution, but you can annoy the developer. So this is the big one. So this is Quarkus. This is if you have not heard of it, it's a Spring-like framework, open source, owned by Red Hat, and it's designed to be Spring, but more for containerized applications. So smaller memory footprint, starts up quicker, that kind of thing. But if you know what Spring controllers look like, this is a Quarkus controller, and it looks basically the same. Annotation-based, paths, tells you what it produces, method type, all that stuff. So very similar to Spring, not as well known as Spring, but it's reasonably popular. So Quarkus has a interesting feature called a developer UI. And this is started up when Quarkus is run in developer mode, which developers have a tendency to do when they're developing another application. And it's under a fixed path, localhost usually, AT-AT, Q, dev, and then that is the config. And you can probably guess where this is going, but this also allows you to edit the configuration properties of the underlying application. Again, That's what I'll show you in a minute. So let's just go right into the demo, because should look reasonably similar to the previous Spring one. Good, start it up. So this is what the config editor looks like. Again, I'm going to be using the same H2 database technique as before. So what the request will do is modify the underlying database JDBC URL to download the exec.call and then execute it on its startup. Luckily, Quarkus, unlike Spring, you don't need to restart the application. It does it for you. Every time you edit one of these fields, it does it all for you. So it made it much easier to exploit. So if we go back to the top one. So again, this should again, we have remote code execution on the underlying machine, the underlying developer's machine. And if we hit refresh, we should see the URL has been added. So you don't even need the URL to exist in the first place. If it doesn't exist, developer UI will create it for you. And then it actually persists. So it doesn't just modify running application, it actually edits the application properties file within the source code to include this new property. So it will then persist over restarts or like shutdown, or it will still be there. So very useful. So this is what it looks like. H2, let me see it right here. A run script from here, and it created the same shell exec and got us remote code execution. So I reported this to the Quarkus/Red Hat security team. It took them a while to kind of understand the issue. I don't think they really got it at first. But once they did, they were very quick. They pushed out a new release of 2.14.2, which was then the latest release. So this impacted, at the time, every version of Quarkus. It wasn't an old version like Spring, it was all of them. And got a CV and a score of 9.6, a CVSS score, which I think is still the highest vulnerability score in Quarkus. The fix, they wanted to get rid of the UI in their 3X version, which would have the version they then released a few months later. They couldn't do that in a minor release, so they had to kind of fudge a fix, which was if the origin header wasn't localhost, it ignored the request, which works. I imagine it would cause problems for some people. So obviously the origin header isn't modifiable by JavaScript, it's set by the browser, and so that does block this, the simple request attacks. So yeah, I've been talking about attacking the developer, but if you think that that developer isn't alone, especially if they're on a corporate network, they'll have local host, as simple request attacks can attack any site that browser can access. You can also use it to attack other systems that are on the internal network of that company. So, for example, there was late last year a vulnerability, another one, in Confluence, which was very simple and was possible via a GET request. In fact, that was the GET request. So, if you knew or you could guess the name of the company's Confluence site before they patched it, and found a way of getting one of their developers or anyone who has access to their internal network, get them to make a GET request to Confluence, and you can get remote code execution on their Confluence server. There'll be others of other kind of systems. Any kind of simple request on any kind of internal site or internal network, you can access and potentially get remote execution, or other vulnerabilities can be exploited. So this is all great. Unfortunately, this class of attack has a limited shelf life. There is a W3C spec, now called private network access, sometimes called local network access, which should fix this when and if it's implemented by browsers. So the way it works is it will essentially force a pre-flight and some other header checking on any request going from a more, what they call a more secure network to a less secure network. So if you're loading JavaScript from example.com, it won't be able to then make a request without certain headers set to a local host or to your internal network. And that will block this at some point. It was Chromium was originally meant to implement this in Chrome 109. That didn't happen, unfortunately. That was meant to come out in January. We're still waiting. They seem to have pushed it back for various reasons. I think there's going to be some issues with compatibility with certain kind of things that want to be able to access internal networks for valid reasons, and they have issues with that. Because it will block it. So if we take a look how this works. So for when this W3 spec is implemented, what will happen is when a request is made to a less secure network, so either an internal network or local host from a less secure network. So if it's coming from an internet-facing site to internal network or local host, or if it's even an internal network to local host, this will have to happen. So before the request is made, again, you get HTTP options pre-flight, but you also get a header that's set. Essentially saying, we're going to make a request to a less secure network. As the server that's going to get this request, are you okay with this? So access control request private network will be true. And only if that server responds with a header saying, yes, that's fine, will then the original request make it through. So that's how this will be fixed. So it's the way the browser works it out. I think it's based on IP range so it does a DNS lookup of the host name and then works out whether it's an internal network. So 172.168.168, blah, blah, blah. One of the private network IP ranges. And if it is, it goes through this method. I'm not entirely sure what would happen if it was IPv6, but that will probably never happen anyway. So the current status of the browsers. Long term, only Firefox is likely to be able to be targeted like this. They do have this RFC on their backlog, but they have essentially no plans to implement it. Chromium was meant to be fixed. It's meant to be fixed late last year, and it keeps getting pushed back. Currently, it's now scheduled for September. Edge, which is Chromium based, is likely to then get it at some point after that. IE you can target IE, although I'm not entirely sure how many developers still use Internet Explorer. So it's unlikely to be a good system to use. Safari, for some reason, never implemented this. They never allow these kind of requests to happen in the first place. So good for them. But that's how it is. So Firefox is the one to target. Thinking about how you get the developer to actually force them to use Firefox. If you can get them to view your tutorial website with this kind of malicious JavaScript, you could probably add some CSS that breaks in Chrome or other browsers and put a little message up saying, we're working on it. Hey, why don't you use Firefox in the meantime? Get them to load up in Firefox. So, conclusion, frameworks have a tendency to assume that things bound to localhost are safe and they don't add any protections. And that's not entirely true and won't be for a while. So things like, I've seen this in Spring, obviously the original Toggles, Micronaut, again, Quarkus, so all of the major Java ones. I've not looked at other languages because I'm primarily a Java developer. So if this is something that interests you and take a look at other frameworks and other languages, I would be surprised if you didn't see similar issues there, because I doubt developers of other frameworks and other languages know about this any more than Java developers do. So yeah, this is probably a useful thing to research if you want. There's likely to be equivalents in Node environment, in Node frameworks, Python, etc. Okay, and that's pretty much it. So there's some background information there and links to the payloads and also the developer applications I used, the applications I used during this talk. There's one Quarkus, there's a Toggles one, a couple of Spring ones that you can use and the payloads to trigger them, and some background information about this. There's another one that's not web-based, but was also vulnerable, I forgot to mention. Redis, which is a kind of a caching system used by lots of web applications, but it itself isn't a web application. But it did have a HTTP endpoint, and it was possible to do a sandbox escape from there in a vulnerability from 2015. And again, you could use a simple request for that. So even if it's not a web framework, there is always the possibility you can get remote code execution other parts of the developer environment. Because again, the developer is likely to have Redis on their system. In fact, if you look at that blog, there is the guy who wrote that created a hot patch to fix the underlying issue as JavaScript. So the vulnerability could be used to fix itself. And so he created a JavaScript payload to which you have to click on it. It doesn't just load up on when the browser loads. I wouldn't necessarily trust it in the first place, but it would fix this underlying vulnerability by patching itself with a simple request to Redis, which I thought was pretty cool. And that's about it. Any kind of questions or?
I cannot see any raised hand.